Hello and welcome. This is question 7 for Edexcel's M1 June 2003 past paper. Okay, so in this question we're given that there's two trains, obviously very well drawn by myself, so I'll take credit. Any copyright will be notified. Anyway, apart from the certain death penalties that are out there somewhere for copyright, what we've got here is two trains that are on the same horizontal plane, or whatever you want to call it, ground, probably should have said that, okay, and they're both initially at rest, okay, so really we're given a bit of a scenario and it's just using SUVAT equations and being able to interpret them into equations, okay. Now, as I said, the first part of this question just asks us to sketch the speed time graphs for between 0 and t. Okay, now I'll just read out the key bits of this little paragraph that they've given you. Okay, so initially they're both at rest, okay, and for the first 12 seconds A accelerates constant rate to 30 meters per second. So from 0 to 12 seconds, in the first 12 seconds it's gone from rest to 30 meters per second, and then remains at this constant 30 meters per second. Whereas B starts when t equals 40. It starts at 40 seconds. Okay, then it accelerates at the same rate A does, but it reaches a higher speed of 60 meters per second, and then it remains at a constant velocity. Okay, and if you want to work out the acceleration both, you can do that, but we're going to do that a bit later on, okay. As I said, for the first part of this, it's just asked us to sketch a speed time graph. Okay, now we know the maximum speed of B is 60 meters per second, and the maximum speed of A is 30 meters per second. Okay, now we need to take into account the time that this is going over. Okay, so we said in the first 12 seconds. So the first thing we need to do is work out the total time that it's going to take. Okay, so what do we draw this axis up to? Oh, good question. Well, we don't just draw it up to anything. Obviously, we know t, the p doesn't start moving until 40 seconds. So it's going to have to be something quite substantially greater than 40 seconds, okay? Now, as I said, it doesn't specify how far it wants it drawn in terms of, to what letter. It's just t. They've just labelled t as the final unit on that axis. But obviously, they want you to draw on the certain starting points. Okay. Now, if you look online, it's just got this kind of. It's just got the A starts at. Really, it wants you to pick out the certain bits, okay? So, really, you don't need to label it in terms of exactly, 5, 10, 15, 20, 25. It just wants you to label the key bits, okay? So, what we're going to do is A starts at 0, starts moving at 0 at constant speed, and, the gradient is an acceleration, so it's a constant line, okay? Constant proportionality. And then when it gets up to 30 meters per second, okay? And at 12 seconds, so you draw down, you get 12 seconds. Okay, then it remains at this constant velocity right up and towards t. Okay, so that's your A. Now, you might want to do that in a different colour or dash it or whatever you want to do. Now, B starts at 40 seconds, so you choose somewhere and write 40 seconds. Obviously, it has to be quite a bit after 12. Okay, and it accelerates at the same rate as A. Okay, now you can work out what the acceleration of A is. Which you would work out to be 2.5 meters per second. That's the gradient of this incline. Therefore, the gradient of B must also be 2.5 meters per second. That's the rate it's accelerating at. So you could do a little SUVAT equation if you wanted to. Okay, we're going to be doing this later. So its initial speed is 0. Okay, so that's u. V is 60 meters per second, and it's accelerating at 2.5 meters per second squared. Okay, and what you want to do is work out the time it's taken, because it starts at 40 seconds, but at what time does it reach 60 meters per second? Okay, so therefore what you'd want to work out is t. Okay, so you know v equals u plus at. Rearrange to get t. Sorry, it's not perfect there. So we know a is delta v over delta t. So you just rearrange that to get t equals delta v over a, because delta v over t is a. So therefore you just rearrange that, times both sides by t, divide both sides by a. So you get t is equal to delta v over a. Delta v being the change in velocity. Now if you sub that in, so it'd be 60 over 2.5, okay, to get the time, you would get approximately 24 seconds. Okay, so what you do is you add on 24 seconds to 40, which obviously gets you 64. You draw a line across that show it, that's reaching a top speed of 60 meters per second. The gradient has to be something, looks like something similar to A, okay, and obviously therefore that reaches its maximum speed at 64 seconds. Okay, and that will continue going up to t. Okay, so that's the speed time graph for both of them. So that's your 3 marks there. So you mark 1 is the shape of A, so going up and staying horizontal, and then second mark is having the same slope as A, and the figures are for the 3rd mark. So 64, 14, 12. I don't think you really need this 64, but it does help when we come on to the later part of this question. Okay, so basically, train B overtakes train A after both trains have reached their maximum speed. Find the value of t, okay? Because this value of t is when B overtakes A. Now, don't get confused like I did and say, oh, it reaches maximum speed, it overtakes it, and go, therefore, B reaches its maximum speed at 64 seconds, therefore it overtakes A at 64. Now, you've not read the question properly, that's because that's what I did. So what we need to do is work out the total distance covered by both of them, okay? Now you can imagine the sort of, it's a bit irrelevant really, because there's obviously there'll be a change in distance here, and we need to take that into account, but really we're not bothered about that, that's just an example. So don't get confused that A has to catch up to B, okay? You can imagine them at the same point, I've just drawn them at separate points, okay? Just so you can show the 2 different particles or blocks, or whatever, trains. Okay, so we need to work out the distance covered by both of them, and then when the distance covered by B is greater than the distance covered by A, that is obviously mean it's overtaking it, okay? So all this now is a case of just using SUVAT equations. Now, what we need to do, obviously, the distance covered is shown by the area under the velocity time graph. Okay, so what you could do is work out the distance covered when they are both accelerating, okay? And then add that on to the area that they're going to continue to expand to, okay? In other words, what I did was, sorry, one sec, just double check what I did. Obviously what I did was on the mark scheme. Okay, so what we need to, as I said, work out the area of these two first, okay? Which is a half times the height times base, obviously you know that. So it's a half times 12 times 30, and we add to that the distance covered by, so this is the distance covered by A, and obviously we want to make, anyway, so work out the distance covered by A, and that is the area of this triangle, which is half times 12 times 30, plus the area of this. Now we don't know how long this rectangle is, but we know it starts at 12, okay? So therefore what you do is you sub in your standard S equals, because there's no acceleration on this part, because the gradient is negative, sorry, it's level, there's no gradient, 0, sorry. Because there's no gradient, we just use V equals ut, or because S equals ut plus a half at squared, S equals ut, because A is 0, okay? So, because we know that there's a constant velocity of 30, 30 times, and then it's times time, but we know whatever time this is, we need to take 12 away from it, okay? So it's t, take 12. Okay, and that's when it, and then we need to make the distance covered by B greater, okay? Or you can make it equal to, and then say after this point, B is greater, okay? So this is the distance covered by A, and this is the distance covered by B. Okay, so we do the same thing, so work out the area of this triangle, which is a half times the height 60, and it's 24 seconds that it takes to reach that speed, so it's a half times 60 times 24. We do the same principle, except we're not travelling at 30 meters per second, we're travelling at 60, and it's t take, now it's not t take 12, because obviously that would be over here, it's t take 64. Okay, So make sure it's right, yeah. And then what you do is you expand, you find out the individual values of these. Sorry, I was just going to go straight to telling you the answer, but I do feel that's probably a little bit in the way of the word cheating. Okay, so I'm going to try to look for a calculator then, but obviously just get my phone up because obviously that's a hell of a lot more quick and easier for me. Okay, so just work this out. So let me get this up, sorry. Okay, so a half times 12 times 30 is obviously 180, because it's 6 times 30, which is 180. So it's 180 plus 30t, take 30 times 12, which is 36, obviously, you know that. And then it's a half times 60 times 24, okay, so if you work that out, just 30 times 24, which is 720. So it's equal to 720 plus 60t, and then take 60 times 64. Let's take 3,840. Okay, and if you simplify it down to get t, you'll get t to be 98 seconds. Okay, so after 98 seconds is a point where B reaches the same distance as A, and because it's travelling at a faster speed, it will therefore overtake it. Okay, so that's the answer to question 7. Sorry, I did fancy about trying to simplify that down, but yeah, as I said, you can do that. I just wanted to give you the basics, look like I've done something vaguely acceptable. Okay, so hopefully that's helped you understand. As I said, they're not actually, A's not actually set behind B. I just drew that as 2 separate objects. As I said, there's no, you don't have to encounter the distance between them. That's just my cruddy drawing. Okay, so thanks for watching. Hopefully it's been of, as I said, some help, and we'll see you in question 8, which is the last question on this paper.